Hi there, Miss Barber here. We now begin our study of a module called Statistics. Statistics is the art and science of gathering, analyzing, and making inferences or predictions from numerical information and data obtained in an experiment. Statistics is divided into two main branches. They are 1. Descriptive statistics. Descriptive statistics is concerned with the collection, organization, and analysis of data. And 2, inferential statistics. Inferential statistics is concerned with making generalizations about and drawing conclusions and predictions from the data that is collected. Data is the numerical information obtained. When you successfully complete the study, you will have learned the following: appropriate sampling methods, be able to construct and interpret statistical graphs, how to compute and interpret measures of central tendency, how to compute and interpret measures of dispersion, the basics of the normal distribution, and correlation and regression lines. We begin with 12.1, sampling, frequency distributions, and graphs. Some definitions. 1. The population is the set containing all the people or objects whose properties are to be described and analyzed by the data collector. 2. A sample includes some of the items in the population. And 3, a representative sample is a sample that exhibits characteristics typical of those possessed by the target population. It is a small replica of the entire population. Example: the officials of a Parks and Recreation Board would like to determine whether the city's residents will support with tax dollars expanding an existing hiking trail to include several more miles of a greenbelt. Part A. Describe the population. The population is the set of residents of the city, not just those who use the hiking trails. Part B. One of the members suggests obtaining a sample by surveying people on the existing hiking trails on a Saturday afternoon. Does this seem like a good idea? And by that, does this seem like you are going to get a representative sample of the city's residents? No, it is not a good idea. The suggested sampling technique surveys only the people who use the current trails on a Saturday afternoon. Those who do not use the trails do not have a chance of being selected for the survey. Sampling method. Number 1. A random sample is a sample obtained such a way that every element in the population has an equal chance for being selected for the sample. The methodology. We must first identify each element of the population, then assign numbers to each element of the population, then randomly select the numbers, and finally assign the elements of the population who have those numbers in the sample set. 2. The sample is a systematic sample if the sample is obtained by selecting every nth item on a list or production line. 3. A cluster sample is sometimes referred to as an area sample because it is frequently applied on a geographical basis. 4. Stratified sampling involves dividing the population by characteristics called stratifying factors such as gender, race, religion, or income. And 5. Convenience sampling uses data that is easily and readily obtained and can be extremely biased. Example: the officials of a Parks and Recreation Board would like to determine whether the city's residents will support, with tax dollars, expanding an existing hiking trail to include several more miles of a greenbelt. Which of the following sampling techniques would be most appropriate for obtaining a representative sample of the residents? Technique A, survey every 5th person who walks into the Parks and Recreation's office. Sampling method B, survey a random sample of persons within each neighborhood of the city. And sampling method C, survey the first 200 people listed in the city's utilities directory. Method B, surveying a random sample of persons from each neighborhood of the city, is the best way to select a representative sample of the entire city. This method ensures that all residents of the city have a likely chance of getting selected. Method A would exclude all persons who do not physically go to the Parks and Recreation's office. This may also leave out persons who regularly use and benefit from the hiking trails. Method C leaves out all but the first 200 residents of the city. If it's an alphabetical order, it could leave out everybody at the end of the alphabet. Data presentation. Let's get some more definitions. 6. A piece of data or data item is a single response to an experiment. 7. A data value is the value of the data item. 8. The frequency of a data value or item is the number of times that value occurs. 9. A frequency distribution is the listing of observed values and the corresponding frequency occurrence of each value. Example, construct a frequency distribution for the data showing final course grades for students in a first-year psychology course. We have the raw data, it's provided for us. Now, in order to construct a frequency distribution, we need to make a T-chart or a table. We let the first column or the leftmost column represent the data items. Those include the course letter grades that are possible, so that would be an A, B, C, D, and F. Now, we're just going to count up the number of times each of those letter grades occur. I'll read them from the left to the right and make a tally mark every time I see the letter. So I'll begin with F, A, B, B, C, C, B, C, A, C, C, D, C, B, D, C, C, B, C, F, A, C, C, D, A, B, C, B, D. Now count those up. For A, there's 5. For B, I've got a bushel of 5 and 2. So that's 7. For C, I've got 2 5s and a 2, so that would be 12. There are 4 Ds and 2 Fs. That is the distribution of the grades for this first-year psychology class. Some rules for data grouped by classes. 1. The classes should be the same width. 2. The classes should not overlap. And 3. Each data item should belong to only one class. Example, the following is a data set of ages of a random sample of 40 college professors selected from all professors at a university. Part A. Construct a frequency distribution with the first class 20 to 29. We observe the data and note that the highest value appears to be in the 60s. The class width is 10. So the next class width following 20 to 29 would be 30 to 39. The one following that would be 40 to 49. Following that class would be 50 to 59. And finally, the last class of the ages would be 60 to 69. Frequency, you count the number of times you see an age group in each class. For the 20s, looking at the data, you will see 4. For 30s, count them: 34, 30, 34, 36, 37, reading across the second row, 32, 31, 30. Going to the third row, you see a 37. Looking at the fourth row, none in the 30s, and in the very last row, you see a 39 and a 38. That's 11 total in that age group. Do the same for the ages from 40 to 49. Count them. Make tally marks if necessary. When you do, you'll find that there are 14 professors in the age group from 40 to 49. Count how many professors are there between the ages of 50 and 59, and we count 5. And finally, from 60 to 69, that is how many professors are in their 60s, turns out to be, I'll give you a moment to count them yourself, 6. Let's continue. Part B, what age range is most common? Now that you've got that frequency distribution, it is easily seen that you've got more in the 40s because there's 14 of them, so the solution would be the 40s. Histograms and frequency polygons. Let's get to some definitions. A histogram is a graph with observed values on the horizontal scale and frequencies on the vertical scale. A frequency polygon is a line graph with observed values on its horizontal scale and frequencies on the vertical scale. Example, construct a histogram and a frequency polygon for the frequency distribution of the ages of professors at a university. Provided here is the frequency distribution we obtained from a previous example. Let's observe. We have class of 20 to 29, frequency 4. A class of 30 to 39 with frequency 11. 40 to 49, frequency 14. Ages 50 to 59, 5 professors in that group. And 60 to 69, 6 professors in that group. To construct either a histogram or a frequency polygon, we begin by making the horizontal axis. Let's label that as the age of the professors. Then we'll make a vertical axis, and remember the vertical axis represents the frequency. Now let's put in some appropriate numbers. For the first class of 20 to 29, the midpoint is 25. For the second class of 30 to 39, the midpoint is 35. And for the midpoint of 40 to 49, that would be 45. From 50 to 59, that would be 55. And the last class of ages, 60 to 69, that would be 65. Now, to determine what you want to use for the frequency numbers, we know that we've got to go from 0 to at least 14. I'll make those scaled to 2 units. So I'll have a 2, 4, 6, 8, 10, 12, and 14. Now, the first vertical bar here, notice it is a bar. I straddle the 25. That suggests that I'm covering the entire class from 20 to 29 horizontally, and it goes up to a height of 4. For the second class, I draw the bar right next to the first one, and it's touching, and it goes up to a height of 11. The third bar has got a straddle 40 to 49, and it goes all the way up to 14. Finally, we look at the next two bars, 50 to 59. We straddle the tick mark of 55 and go to a height of 5. And the last one for 60 to 69-year-olds, I mark 65 as the midpoint, and it goes to a height of 6. Again, notice that with the histogram, the bars are touching. To make a polygon, the frequency polygon, we connect the points that are midpoints. So for example, where the 25 is, we draw a straight line all the way up to 25. For the second bar, let's mark the 35 at the height of 11, and we connect those 2 points. From that point to 45 and a height of 14, connect. Notice that these lines are not being smoothed out. They stay straight lines. For the 55, we mark the height at 5, connect that point to the previous point. Similarly, for 65, mark the height of 6, connect that point to the previous, and then finally finish it off from the height of 6 with going over 65, draw it to the bottom. The histogram is the shaded region under each of the 5 bars, and notice that they are connected. The frequency polygon is just the line segments connected at the points. It does not include the bars. Stem and leaf plot. Definition. A stem and leaf plot is a tool that organizes and groups data while allowing us to still see the actual values of each data item. The left group of the digits is called the stem, and the right group of digits is called the leaf or leaves. Example, the following is a data set of the number of miles 20 employees drive to work. Part A. Construct a stem and leaf plot of the data. To create a stem and leaf plot, you need a table or a T-chart with the words stem and leaves. The stem represents the tens digit, and leaves represent the units digit. The stem, again, is the tens place, and so if we look at the miles, notice you've got some that's less than 10, so the stem on that would be 0. We've got some mileages in the teens, and so the tens digit number for that is 1. We've got some mileages that are also in the 20s, so for the tens digit place, that would be by 2. We've got some mileages, at least 1, that's in the 30s, so we need a stem of 3. And finally, the longest distance is in the 40s, and so the tens digit is a 4. For the leaves, just write down the numbers as you see them for each correct stem. Reading on the table, for the 0 stem, I see a 3, an 8. In the second row, I see a 3, and then a 4. On the third row, I see none, and on the last row, I see a 9 miles. Now let's go back up to the first row. The stem that begins with 1, the first one is 12, we write down only the 2. For 18, you write only the 8. And again, we see 12, we write down 2. In the second row, in the teens, you see a 15, write down only the 5. On the third row, the next mileage that we see in the teens is 17, so let's write 7. Reading across, the next one we see is 16, so we write 6. Coming to the last row, we see 12 miles again, so we write 2. And then we see 14, so you write only 4. Let's go to the 20s. In the first row, none, but in the second row, I see a 25, so the leaf would be 5. For 21, we list only 1. Going to the third row, we see a 27. The 2 is taken care of in the stem, so for the leaf, you put in 7. Reading across, we have a 21. The 2 is taken care of, so you just put in 1. And finally, on the last row of numbers, we have 26 miles. 2 is in the stem. We write down only the 6. Let's go for 30 miles, or in the 30s, and there's only one of them. It's in the last row. It's 35 miles. 3 is in the tens digit. 5 goes in the units. Then let's look for 40. In the 40s, in the third row, we have 43 miles. The tens digit has the 4 in place, so the units digit would be the 3. And this is our stem and leaf plot. Notice that we get to see every single data value. What is the greatest distance driven, and how about the least? Well, the greatest distance we can see from the stem and leaf plot would be 43 miles, and for the least, just 3 miles. We look where the stem is 0. Part C. What is the most common distance? Looking through, it appears that we have 12 3 times, so the common distance is 12 miles. Deceptions in descriptions and visual displays of data. Statistical thinking will one day be as necessary for efficient citizenship as the ability to read and write. That was spoken by H.G. Wells. When examining statistical information, consider the following. Was the sample used to gather the statistical data unbiased, representative, and of sufficient size? Is the statistical statement ambiguous? Could it be interpreted in more than one way? 3. Are there distracting designs or improperly scaled graphs that are or could be misleading? And finally, 4. Who or what entity has a vested interest in a particular finding? Example. Identify what is missing, wrong, and or misleading. Part A. A help wanted ad states, salesperson wanted for Ryan's furniture store. Average salary, $47,000. The term average gives an implicit suggestion that all employees earn around $47,000. However, consider business with 4 employees where 3 salespersons earn $25,000 per year and the store manager earns $113,000. The average or mean of the salaries is $47,000. However, given this pay distribution, should you expect a starting pay of $47,000? Part B. Consider the graphs comparing the change in price of stock A to stock B. At first glance, it appears that stock B's price is increasing much more rapidly than stock A. The vertical axis for stock A and stock B are both the same linear length. However, the vertical axis of stock A starts at 0 and increases in 5-unit increments to 40. The vertical axis of stock B starts at 25 with 1-unit increments to 35. The scaling of stock B gives the misleading impression that stock B increased at a much higher or much more rapid pace. Part C. Consider the graphic representation of salaries by level of education. This data is collected from www.bls.gov. Look at this data. For no high school diploma, the annual average salary is $27,650. To high school diploma, the salary increases to $36,500. What happens, though, is you are showing a linear increase, but representing it by area. Let's be mindful of what is called the area principle, which states that the area occupied by a part of the graph should correspond to the magnitude it represents.